looking at data. Am I sharing my screen? No.
Not yet.
I'm not sharing my screen, right?
No.
Oh, okay. Let me do that. Ah, dear, I'm so cold. Can you see my screen now?
Yes.
Okay. So we're going to look at data types, right? There are a lot of data types, but we'll look at 4 main data types. 4 main ones. We will look at strings. We will look at numeric data. We will look at Boolean. And then we will look at date. Data types. These are the main ones we want to focus on. There are a whole lot of others, though. There are a whole lot of others. We have XML data. XML. We have what is called club. Okay, let me just explain what these are first. So XML is just for storing XML data. I would explain what we would explain later on what XML is for. So this is for storing XML data. And this one, club, is an acronym for character large objects. Character large objects. Then we have blob. And that is binary large objects. And then we have JSON. I'm sure you've heard of JSON. Have you? Anyone here done API?
No.
JSON is for storing JSON data. Those who have done API would have come across JSON. JSON data. But we're going to concentrate on the first four. The other ones you would hardly use the other ones actually, unless you go into certain specific fields. But these first four you would use all the time, especially, in fact, you will use all the first four. Fortunately, we touched on the last one, the last of the four, dates, in our last lesson. I think we dealt extensively with dates. So today we will look at strings, numeric data, and Boolean. Boolean is rather very short, but the emphasis will mainly be on strings and numeric data. Strings. I believe we all know what strings are, right? And so why are we doing this actually? Why are we doing this? Let's to give you a sense of why I thought we should do this. Assuming you go into an organization and they want to build a database, and as a data analyst or the data architect or the data engineer, they've asked you to build a database, you will need to know the data types that you are working with. Even if you are not a database administrator or a data engineer, it's good as a data analyst to know the data types that you are working with, because all these data types have got their own characteristics and then they have their storage limits. If we, let me see if I can look for something. Let me just take a name, employees. You would see here, this is where the data types are defined. The data types are defined here. You see int, you see end varchar, you see date, you see varchar, you see date, you see char, you see int, you see date time. These are the data types we want to deal with today. Right. So let's see. Strings. Let me start from the type of strings that we have. You know, a string is usually a character of what? A mix of alphanumeric characters. It could all be alphabetical characters, or it could be a mix of alphanumeric characters. Now, these are what strings are. So let's take some examples of the types of data that are strings. The first one is what we call the varchar. The varchar data type, sorry. Varchar. Varchar data type. Now, this is a string of variable length. That's why it's called varchar. A string of variable length. In SQL, this varchar can take character lengths up to 8,000. Character lengths. Up to 8,000 in SQL. It can take different ones depending on what you are looking at. I was just checking, I was just Googling something, and then I saw, where did I see it? Let me see. Let me just Google it. What is varchar? It can be up to 64,000, 65,000, thereabout, varchar in SQL. Yep, from 0 to up to 65,000 maximum length of strings. But in the SQL, in most SQL database servers, it would take up to 8,000. So when you are building a database, you need to know the capacity of what your data types can, the capacity that your data types can take. So that's the first one. The first one is the varchar. The second one is nvarchar. Nvarchar. Now, this is used in handling non-English characters, including the Unicode. So characters like Chinese, Japanese, Russian, Korean, Hebrew, Greek, Arabic, and I think Yoruba characters are more like English characters, aren't they? But then when you look at the fact that what are those things that we put on top? What are they called? I've forgotten the English name of those things. The accent marks. So this is used in handling Unicode characters, which are non-English characters. So assuming you get a job in a Chinese company, and they say you should work on a database, create a database which is in Chinese. You don't need to know the language, but you need to know what type of data and how to handle the data. And then you need to know that it is nvarchar that you want to use instead of varchar. Handling non-English. Non-English characters. Unicode. Unicode. Chinese. Chinese. Did I spell Chinese right? Chinese, Russian. Russian, Korean, Arabic, etc. Greek, Hebrew, all those languages that use different characters other than the English character. So that's varchar. Now, this has got a maximum capacity of 4,000 characters. So it is half what the varchar would handle. And so if we look at it in terms of bytes, each character in varchar is 1 byte. Each character in varchar takes up 1 byte. So each character in an n varchar domain will take up 2 bytes, which is why it can only take up to 4,000 characters. The next one is char. And who can tell me what this is? We use this a lot. So this is a single length string, single length, 1 character. That's just char.
Can you please give an example of that char, please?
True. False. Male. Female. You get it?
Yes, I do. But once you now have to type it out in full, that takes away from char. Okay.
When you use M in the database as a character type, we know it's male.
Yes.
Yeah?
Yeah.
Now, let's go back to this one. In a database, the varchar automatically defaults. I mean, you can't have a word. We haven't yet come across any single word that is up to 8,000 characters. I haven't seen that yet. But it doesn't mean it cannot be there, which is why that allowance is made to accommodate any length of character. However, in most databases, the varchar and varchar defaults to 30 characters. So in a situation where it is not specified, like when I opened, see here the title varchar 10. It will take 10 characters. It defaults to 10 characters, right? So it's been set to 10 characters. So you're looking at title like Dr., Mr., Mrs., Prof, Professor, that kind of thing. Do we get that? Now, the forename is 30 characters. However, if this 30 was not here, it would automatically assume that it is 30, unless it is specified, right? So assuming you want to, so in this case, for example, in title, for example, it's been explicitly specified here as 10. So it would only take up to 10. It will not take more than 10. But if it wasn't specified, then it could take up to 30. Right? However, like I said earlier on, this 30 is not the limit. The limit is 8,000.
Which means that it could go beyond the 30, is that right?
Exactly, yeah.
Okay. Because the one that we have is 50.
Okay. It could go beyond the 30. So and that also reminds me, most different database management systems have got different default limits. So which one are you using when you say 50?
The one we had from Power BI.
Okay, so that has been set to 50.
Yes.
But what I'm talking about is the default position.
Okay.
Do you get the point? So if
yes.
it wasn't set to 50, the default position, if 50 hadn't been there, would have been 30.
Okay. Okay.
Another thing too that you need to take note of is this. So is assuming the forename here. Okay, let's even run a query. Let's to show you that. Select. Let's see, select forename. Where do we want to select it from? From employees. You've seen this table before, so it shouldn't be an issue. Okay, I'm using the training, that's why it's right. So if we want to do this, we want to see if, for example, I set the select forename. There's something I haven't taught you, I haven't showed you yet, so it's giving me a bit of cast. The keyword cast, we haven't come across it yet. But I would explain what it does. If there is time, maybe next week, we can look at it. Forename as varchar. Varchar 5. If I were to run this, something is going to happen. Look, before we do this, let me comment this out. Select forenames from employee. Let's just run this and see what happens. So we have some names here that are, let's look at Rebecca. 1, 2, 3, 4, 5, 6, 7 characters. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but assuming I come here and then I ask it to set this to 5, what is going to happen? You would see that. Look at that. Rebecca has been cut short to 5. This has been cut short to 5. So setting it below the limit, that it's the default limit, could truncate your data, as in this case. So we see here that the data in certain instances have been cut short, have been truncated. And it's simply because we have limited the number of characters that it can take. Right? So whilst 30 is the default position, assuming you have like some names from certain places, let me pay in, for want of a different example, let me just use there's a country where the names are very long. Is this Sri Lanka? Yes, I think Sri Lankan names are very, very, very long. So if you're dealing with data from a place like that, you wouldn't be setting your default position to 30. Like we've just seen, somebody said they have a position of 50. You could change the position. You could change the setting in your table, and then it would be able to accommodate whatever it is that you want it to accommodate. Is that okay?
Yes.
Right. In much the same way, if we were using Unicode or non-English characters, we would run this the same way, but instead of varchar, we use end varchar, and it will give us the same results. Right. So like I said, this truncates what we have in the database, but we can just have it back here. We can set it back to 30 to get our required position. So like I said, this has got a maximum length of 8,000, max length. It's seeing this as max length 8,000. One byte per character. If we were to do this in Unicode, then that would be end varchar. End varchar. And this will still take 30. However, the limit on this is that it has a maximum length of 4,000. 2 bytes per character. The next data type we want to look at is the char 1.4. data type. So that one would look something like this. Char. We can use the oh yeah, I said cast. I've not told you what cast is. Cast is used in changing the form of a data type. It's used in changing the form. That's what it does. But we will see the use when we really treat cast. So let's say we want to change gender. We want to see gender. Cast gender as char. And like we said, char is character how many? 1. So if you look in any database where it has char, let's see, employee. You see char here is 1. This 1, is there another one? No. Right, so it should be the same thing if we were doing Unicode. It should be the same thing for Unicode. The only difference is this becomes nchar. Nchar. Another string type is text. Text. And how do we handle this? We cast again, whatever it is that we want to cast as text. This here takes quite a huge amount of data. Can take a huge amount of data. It takes up to 2147 483 647 characters. This red line here is simply because we don't have anything similar to that in the database. That's why it's turned everything red. So it's nothing to worry about. And all of these we taken from employees. Right. Okay. So these are the string data types. So we have varchar, we have end varchar, we have char, and then we have text. These are the string data types. Then we come to numeric data. Here again, we have a number, about 1, 2, 3, 4, 5, about 5 types of numeric data. Let's look at them one by one. The first is 2.1. Exact numeric. Exact numeric. Two point two is what is called the tiny int. We have small int. We have int. We have big int. These are the 5 numeric data types. So what are these? Now, the exact numeric data means that you want the data to appear exact in exactly numeric form. No, it should be a complete whole number, right? It should be exactly how you want it. So let's look at some examples. Let's say we select. Let me comment these out. So let's assume that, okay, no, this should be here, this should be there, this should be there, this should be there, it should be there, it should be there. We're going to cast again here. So select cast 1 as, what is this? 1. That's tiny int. That's the one as tiny int. Still from employees. Incorrect syntax. Why is this like that? So this here, it handles characters from 0 to 255. From 0 to 255. Now, if anything goes outside of this range, if there is anything outside of this range, it will throw what is called an arithmetic overflow. So if, for example, we say we should cast -1, you see -1, for example, is outside of this range, and 260 is outside of this range. If we use numbers using tiny int specification, it would throw what is called an arithmetic overflow. Let me see if we can do that. I don't know why this is on the line. Incorrect syntax. Why is this? Where from this? Syntax from. Right, okay. I can guess what is happening. I'm just trying to see if I can get an example of it in the bit table. And there isn't an example, but I think you get what I'm trying to drive at. So this here takes characters from 0 to 255. Let's look at, if I run it, it's not going to work because this is not, it's not seeing this in the table, in any table. So I will not run it. And then we can also have from the 10,000. As small int. Small int. Now this takes figures from minus $32,768 to $32,767. Then we have int. This one is from 1 million. But as a matter of fact, int can take any whole number from minus anything to minus anything, so long to up to positive anything, so long as it's a whole number. So int, that is why int is the most used data type or data type specifier in the all over the place. You hardly hear of tiny int, you hardly hear of small int, but you would always hear of int, because it cuts across the whole spectrum, except maybe one area where maybe it doesn't go. So this takes that's int. Almost all whole numbers. Almost all whole numbers. Specifically between the range, but it can go beyond that, but it's given that. Minus. This is quite a huge number in billions. 2 billion 147. For all these are on the internet. You can actually check it up. 483 647. 2 plus Then also we can cast a number as big int. Now, big int, as the name implies, is really, really, really big. It's big. I don't even know how I can describe it, but it's big. I'm sure that is why int has been restricted to this. The big int is quite big. It's very big. So it takes anything from 9. Anybody who can read out this number should please read it out, because I don't know how to read it. 223 372 036 854 775 808. Right, so this it takes up to all of this. You can take anything up to this or more. So if we write this in this is 2 raised to power 63. 2, that is minus to positive 2 raised to power 63 plus. That's 1. Right, so the numeric decimal. This is numeric. Then we also have numeric decimal. We have numeric exact. Now, these are the various forms of numeric exact. Numeric exact. Actually, so I better name this 2.1, 2.11, 12, 13, 14, 15. So here, within this range, within the tiny int, small int, int, and big int, these are all whole numbers. These are all whole numbers. The next data type, the next numeric data type is the decimal. Numeric decimal. Numeric decimal. Excuse me, guys. It looks like somebody's at my door. Let me check. I'll be back in one moment. Sorry about that. I have some dogs and I have visitors, so. Can you see my screen?
Yes, we can.
Okay. I don't know where my volume this thing is. Right, so decimal data, so let's look at it. Let's look at decimals. So if we have something like this, 2.2, 2.2, 2.2, 2.2. Assuming I want to do this operation, select. And let's say somebody give me a number. 23.7 divided by 2.1. Right, if we just take this and run, just this one, and execute. It doesn't give us anything. As numeric. Oh, this gives us a whole number. I didn't want a whole number. Okay, let me change these. 22. So it gives us 11. Right, I see what is happening. Because I've specified it as a numeric, it's defaulting to a whole number. It's giving me something from here. From numeric. So I need to specify it as a float. So decimal data is represented as floats. And if I do that, then I can have this. Now let's see something interesting would happen here. We have some very interesting things that we can do with this. Now we can specify this to come out as we can restrict the number of decimal places that we can have here. Can restrict the number of decimal places. So for example, in this the result we have here, we have 1, 2, 3, 4, 5, 6, 7. Let me see. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 digits all together. We have 8 digits all together. We can restrict the results to show just a particular amount of number of decimal places. Sorry, one moment. Let me mute this thing. Sorry, one moment. Somebody wants my attention. One moment. Sorry. Yeah, so where did I stop? Yeah, I said we can restrict the number of decimal places, right? So here, for example, we can, for example, say that there are 8 here. Let me change this. 22.7 divided by 1.21. That's flip. Come on, select. What's happening? Okay. 1, 2, 3, 4, 5, 6, 7, 8. One moment. Let me see what I have here. Looks like that is something is wrong somewhere. Right, but this is what we get if we run this as a float, as a numeric, as a decimal data. And this is called the approximate float. Then we can also have Boolean. I'll come back to this. Something is wrong with this thing. I'll come back to it later. We can also have the Boolean data type. Boolean data type, which is simply true or false. True or false. Which actually, in computing terms, because there is nothing like T or F, is actually 1 and 0. Did everyone get this, what I said here? Is that clear? If it's not clear, let me know so that I can explain.
Yes, can you please explain?
Right, so true or false, which is Boolean, right? That's
Yes.
just two types, either true or false. Now, computing language is not in, computers don't know how to read letters. They only read numbers. So computer language is binary, either 1 or 0, where 1 is true and 0 is false. Does that make sense?
Yes.
Right. So if I say, for example, that if I ask it, for example, to cast something, and like I've said, cast is used in changing the data type. Cast 1, for example, as a bit. You know what bit is? In computing, bit is what? 1 is a bit, 0 is a bit. So which of these will it cast it as? I have to select first. Syntax error. Why is this giving me an error? Okay, let's see. So cast 1 as a bit, it gives me 1 because 1 is a number. Is 1 a number? Yes, it's true. So that is, if it's a number, it's true. If it's not a number, it's false. So if instead of 1, I put 20, let's see what the result would be. The result is still 1 because this is true. This can be cast as a number, 1. But if I put this here, straight away you see that it's what? It is underlined, which means that it's invalid. It doesn't hold in this frame. So we can't even use it. But let's try something. Let me try something like 0. What will 0 give me? You see that 0 gives me 0. So 0 returns false, where it's not showing that there is, though 0 is a number, but it's showing false here. If I put 200, it will show that this is a number, this is still 1. Okay, I see what has happened. It still gives me 1. Right. And the last data type that we will look at, so this is the Boolean data type. It returns only 1 and 0, true or false. The last data type we'll look at is the date data type, which we actually looked at the last time. Date. Right, so let's see what we get here. Select. We all know about get date, right? We all know about get date, which we say would give us today's date. We did that the last time. So this gives us today's date. But assuming we don't, you see, this date here gives us the year, the month, the day, the time. Assuming we don't want all this information, we just want a specific part of the date. So we're going to change the results type, right? And like I said earlier on, we use cast to change the type, the data type that we want. So we cast this as get date. As date. And what this is going to do, see what it's going to do. See what this is going to do. This gives us just the dates part. It gives us just the date. This is correct. Okay, so this should come back here. This is the whole date, including the time, and this is just the date. In much the same way, we can cast this as time just by changing the date there to time. And this will give us just the time bit. So assuming we just want the time part of it, then and if we run it, it should give us all three. This is just the time part that we have. Let me see if this will change anything. I'm just experimenting with this. Yep, that's what I want. So this gives us the date and the time. Do you have any questions? Like I said, I'll come back to this here maybe when we meet next time. I'm not sure what happened with this. I'll go and have a look at it again with the decimal type. Something went wrong here. I'm not sure what it was. So I'm going to look at it again and then come back to you. So basically, these are all the data types you'd need to know. All the data types. The different types of strings. The different types of numeric data. Dates and Boolean. That's all. That's all you need to know. There is another thing I would like us to go through, handling strings. So like now we talked about handling dates the last time. We've talked about data types. Also, it would be good for you to know how to handle strings. I don't think there is enough time left. We have just like 26 minutes left for us to do that today. We wouldn't be able to get anywhere into this before the time runs out. So I'll rather leave it for the next lesson. But I thought I could do both today. So the next lesson, we will look at this error here. This is actually, there's an error here. Yeah, we will look at it. And then we will look at handling strings. Okay. Any questions for me?
For now, no. On my end, I guess. But we're going to, like, maybe if we have questions while going back to the videos, we can always reach out.
Okay. Okay.
I think someone else wanted to say something.
Yeah.
Thank you.
Yeah, I just wanted to say, Godwin, it would really be nice if we can have a set to really do all these things.
If you can have what?
A data set to work with, like a practice.
You can use your data set. You see, like this one, I haven't used any data set for this. It's because of the issue of data set. That's why I'm not even using a data set. I'm not using my data set. I'm only looking at it to guide me to do certain things, but I'm actually not using this data set.
Yeah, okay.
You
No
get that? The
question.
same thing, the
Yeah.
last time too, I didn't use the data set.
Yeah. Thank
Which is why I'm only doing general topics, which don't require the data set, but which are equally important. I mean, these are things that you actually need to, if you're doing data, these are things you need to know. The thing is, I don't know how I will be able to transport my data to you. That's the whole problem. It's quite a big data. I don't know how I would. It's big, but it's not so big. But it's I'm not sure. I'll see. But we can work with your data if I'm able to open it up. You get what I'm saying? Only I have not been able to open it.
Yeah, we'll try. I'll try it in my time. If I have any questions, I'll send you a message.
Okay, cool. So can I stop sharing so that I'll wait for another 2 minutes. Anyone has questions? Let's see. Let the questions come. Otherwise, shall we call it a day?
Can I stop recording now?
Yes, please.
Yes, thank you very much.
You're welcome.